Day class. This is Mr. Adewale. We are in for physics again. Today we are considering motion. Motion. What is motion? Motion basically means movement. Movement from one point to the other. That is motion. And there are various types of motion. So we're going to consider them together. We have linear motion. Linear motion also means translational motion. Let's check them together. Linear motion or translational motion, and that's talking of motion on a straight line, movement along a straight path. So we have like a moving car. A moving car is an example of an object that undergo linear or translational motion. Random motion, that's motion in an irregular pattern or manner, irregular zigzag pattern or manner. So like we have motion of smoke particles from the chimney, smoke particles from the chimney. Rotational motion, that's motion about an axis, So rotation of the heart about its axis, rotation of a moving fan, a moving ceiling fan. So when you see the blade moving, that's a rotational motion. Oscillatory motion, that's a to and fro movement, like you have the motion of a pendulum ball, here and there movement. Vibratory motion is a motion of a vibrating body about a point, like you have a turning fork. So these are types of motion. You do well to still check some other examples under each of the types of motion. Right now, quickly go into the equations of motion. We are considering, and then we solve some questions under motion. Let's consider the equations of motion. Equations of motion. What are the equations of motion that we have? The equations will help you solve some calculations on it. Number one, we have V equals U plus AT. V equals U plus AT. The second one, we have S equals UT plus half AT squared. Again, the third one, you have V squared equals U squared plus 2AS. That's the third. Again, we have the fourth one, S equals V plus U bracket T all over 2. So these are the four equations of motion that we have. And again, V is the final velocity. U is the initial velocity. A is the acceleration. T is the time taken. S talks of distance covered. So these are the definitions of parameters of final velocity, initial velocity, acceleration, the time taken, and hence the distance. So in applying all these equations of motion, if you have a question, you look at the question, check the parameters given, then you look for the most suitable equation of motion to solve the question. Is the one you use, is the one you apply. Now you're checking out the parameters. So the first one, look at it now. The first one now, S is not air. Here now, V is absent air. Here now, T is absent air. And here, A is absent air. So each of them have their various applications. So you must know when to use which of the formulas. Each of them, they have their application. So you check the parameters in the question given, then you know the appropriate formula to be used. So it's very important. Now, we're going to solve some questions. But then, let me say this again. Now, points to note. I want to give some points to note. So these are the points to note. If you want to solve questions with the equations of motion that we have been given, these are the points to note. when a body starts from rest, when you say that a body starts from rest, the initial velocity, u will be 0. When a body goes to rest or a body is brought to rest, v will be 0. You have to be on the outlook for all of these points as you solve your questions. If you don't get to know this now, you will fall short many times. For motions under gravity, that's a free fall. Now you know the law of gravity now. Whatever goes up must come down. So your acceleration will be returned to plus g for what is coming down, because that one is obeying law of gravity, coming down. So g is what? Acceleration due to gravity. So a will be plus g for downward motion. A will be minus g for upward, whatever is going up. Just know that your a will turn to minus g. If a body is released from a height, something is coming from up, coming down, u will be 0. If an object is thrown vertically upwards with an initial velocity u, then the final velocity will be 0. When an object is thrown upward, then the final velocity will be 0. When the body is released from a height, u will be 0. Please, you have to note this again. Please note this and internalize these points systematically. It's very important. Now, the reason why people make mistakes solving questions with equation of motion is when you have not mastered all this. When you don't know all this, there's no way you will get the questions given. So right now we're going to solve some questions. I have some questions here. We're going to solve them. Then you'll be given some exercise to work with, and you do good. You do well to put your answer in the comment section. Please don't just check. Ensure you solve the questions. They are very crucial. These are vital topics at every level. Now you will need this list. God bless you. Thank you. Now, the first question now. A car starts from rest. What does that suggest? U equals 0. A car starts from rest and moves with a uniform acceleration of 30 meters per second square. Now, when you see meter per second square, you know that's acceleration. For 20 seconds, that's time. Calculate the distance covered at the end of the motion. Now, if you consider the 4 equations given, now write out the parameters. So now the parameters now to that question, u is 0. Now acceleration, which is a, is what? 30 meters per second square. And what again? Time is 20 seconds. As a good physics student, you must first learn how to itemize the parameters given, and that will give you a clue to what or which equation or formula to use. All right, if you consider the equations that you have been given, you will see that all right, you have a, u is 0. So which of them is most applicable? We want to get the distance. Distance is s. Now we want to get the distance. Let's put it there. Distance. Want to get the distance. So v is not part of it at all. So this will be the most appropriate. ut plus half at squared. This is the second formula given the other time. So I want to get distance. S will be, this is 0 times t times 20 plus half a 30 t 20 squared. You know, anything multiplied by 0 will be 0. That will be half. Multiplied by 30, multiplied by, this is 400. Here one, this is 15. 15 times 400 will be 6,000 meters. So S is 6,000 meters, or you call it 6 kilometers. 6 kilometers. I hope this is clear and straightforward. The second one. The second question. A train with an initial velocity of 20 meters per second. The unit of velocity is meter per second. A train with an initial velocity of 20 meters per second is subjected to a uniform deceleration. Deceleration is also a retardation. That's negative of acceleration. To a uniform deceleration of 2 meters per second square, the time required to bring the train to a complete halt is the time to bring it to a stop is initial velocity, which is u, equals 20 meters per second. What again? Deceleration. deceleration is what? That's, I've told you, that's negative acceleration. That's minus 2 meter per second square. What again? That to calculate the time. Time taken, we don't know the time. Now, for the train to be brought to a halt, then we know that v will be 0 when you are, it has been said the other time. Now, when an object is brought to rest, v will be 0. So what do we do here? Let's take the first formula, v equals u plus at. We want to calculate our time. So v minus u all over a will be what? Will be time. So what's v? Is 0 minus u minus 20 over a acceleration, that's minus 2. That's why it has said deceleration. Deceleration will be negative of acceleration equals t now. That will be minus 20 over minus 2 equals t. So our time will be 10 seconds. Time is 10 seconds. The time to be brought to rest is 10 seconds. I hope that is clear. That's 10 seconds. 10 seconds. 10 seconds. Thank you. The third question, a motor vehicle is brought to rest. That's v now equals 0 from a speed. So the speed is 15 meters per second in 20 seconds. That's time. Calculate the retardation. Retardation is the acceleration that is bringing it to rest. That's negative acceleration again. That's also the same thing as deceleration. All right. So let's check that together. Let's do it together. A motor vehicle is brought to rest. So v will be 0. Speed, that's what will be initial speed now, is 15 meters per second. And time is 20 seconds. You have to calculate a now. That's negative acceleration and that's retardation. That's what we want to get. Alright. So what do we use? Let's check our formulas now. V equals u plus at. V is 0. What's u? 15 plus a. A now, we don't know it, so let's put a and then times 20. Minus 15 will be minus 20a. Minus 15 will be 20a. 20a. So a will be minus 15 all over 20. 5 divided by 20 to get a. I hope this is clear to us. You know, from here, this will give 15 plus 20a. So when you bring it here, that will be minus 15 will be 20a. And this is minus 3 over 4. And that's the same thing as minus 0.75 meter per second square. That's deceleration. So it's minus because we have been asked to find its deceleration. That's why it's minus. You can see from the question, it's minus itself. That's retardation. I hope it's clear. Alright, the last question there. V, the velocity v of a particle in a time t is given by the equation. This is the equation of velocity. So that equation represents velocity 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. We want to find acceleration and we have time 5 seconds. Velocity, and we know acceleration is what? Acceleration is what? Change in velocity over time. That's velocity per unit time. Alright, so let's do it together. Velocity equals 10 plus 2t squared. To change velocity to acceleration, let's differentiate this. We will bring little differentiation into this now. When you differentiate it now, dv over dt. And this is acceleration now. That's acceleration now. Acceleration is what? Is velocity over time. Dv over dt will be, now when you are differentiating, this one, whatever does not have the function will turn to 0. We are differentiating velocity with time. This one does not have time, so it becomes 0 automatically. Whatever does not have that quantity time now will be 0. We are differentiating velocity with respect to time. So this one does not have time, so it's 0 automatically. Plus, if you want to differentiate this thing now, it will be 2 times 2, that's 2 times 2, times, now bring t raised to power 2 minus 1 is a formula you should know. This will be 4t raised to power 1, and that's 4t. Now you may be wondering how I got this. I will explain. So we are given time equals 5 seconds. So time equals 5 seconds. So you now input it. That will be 4 bracket 5, and that's 20 meter per second square. Don't forget we are looking for acceleration. Then it will be 20 meter per second square. But let me quickly explain what I was saying here. When you are differentiation now, this is it. When you have a function like x equals y equals as raised to power n in differentiation, if you want to differentiate this now, if you want to differentiate y with respect to x, this will be, is a formula you should know. A, you bring this one back, multiply by n, s raised to power n minus 1. So this is how to differentiate. That's what we have engaged here. So when we now have y equals, so let's say we have v equals 10 plus 2t squared. We want to differentiate v with respect to t. This one that does not have that t will be 0 automatically. This one will now come back 2 times 2 t raised to power 2 minus 1. Like we have it here. That's how we have 4t raised to power 1. And that's 4t. Then you put 5 there. It has been given the question. That's how we got it. Please check this and check this. If you have problem understanding this thing, you can still signify at the comment section. So right now, you'll be given some questions to try out. Following all these formulas, I believe you should have no problem solving questions under motion. But in case you still have any difficulty, do well to signify at the comment section. Again, if you are checking, you are visiting this channel for the first time, you will do well to subscribe. You will do well to subscribe to the channel, and again, press the notification button, share with your friends, and like it. Then drop your comment at the comment section. There you can have follow up to whatever challenge you have and have access to our new updates. God. Alright, so these are the questions you will do now. Number question 1, a bullet fired vertically upward from a gun held 2 meters above the ground reaches its maximum height in 4 seconds. You have to calculate the initial velocity. Question 2, a car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? The third one, a car accelerates uniformly from rest at 4 meters per second square. How far will it travel in the 5th complete second? So you have to calculate the how far it travel the 5th seconds, not the 5 seconds, the 5th seconds. Number 4, the distance x meters traveled by a particle in time t seconds is described by the equation x equals it. So this distance, x equals 10 plus 12t squared. Find the average speed, and you know speed is what? Distance over time. Find the average speed of the particle between the time interval t equals 2 seconds and t equals what? 5 seconds. I think this question 4 is like the question 4 in the examples that we've considered. So please do well to attempt all this and leave your answer at the comment section, and please don't forget to subscribe, to press your notification button, to like and share with your friends. So we look forward to hearing from you. God bless you. Thank you.